Let's have a look at a couple of problems. This one involves calculating the enthalpy change of combustion for the following reaction involving hydrogen. Have a go and then we'll talk through the solution. So let's write out a balanced equation first. Hydrogen combusts in oxygen to give water and nitrogen. This is the enthalpy of combustion, that's our unknown value. Now let's put the elements in their assigned states on this line over here. So we have nitrogen as a gas, hydrogen as a gas, and oxygen as a gas, and then we balance the elements. Now we're going to draw an arrow from the elements to the reactants and products, and this time they're pointing upwards because we are forming the reactants and products from the elements in their standard state. Let's put the values in. So in this case we're going to use the value for formation of water and multiply it by 2 because we have 2 moles of water. And now we can put the value in for hydrogen. So the thing to remember here is that the enthalpy change for oxygen and nitrogen is 0 because they're both elements. Now let's try to identify two sets of arrows that do not oppose each other. So that's one and that's the other set of arrows. So let me make it a bit clearer by drawing the routes. So one route goes from elements via hydrogen to nitrogen and water, and that's route 1, and the other route goes directly from the elements to nitrogen and water. So route 1 is equal to route 2, so let's put that down in an equation. So we rearrange the equation now to give us delta Hc on the left hand side. And if we solve this equation, we get an answer of minus 623 kilojoules per mole. So hopefully that was okay for you and you were able to solve this problem. Let's look at the one that's coming up next. Let's have a look at problem number 2. Let's try and solve this. So first we're going to write out a balanced equation like we did before. And that's our unknown, which is the enthalpy change of reaction. Now we put the elements in the standard states and balance it. And then we're going to draw 2 arrows pointing upwards because we've been given the values for enthalpies of formation. So we need to remember that for the elements, the enthalpy change of formation is 0. So let's try and find out two sets of arrows that do not oppose each other. So we've got set 1 there and set 2 there. Put the values in, so that's for the Fe3O4, and on this side we're going to put the values for water. We need to multiply this by 4 because we've got 4 moles of water. So that's route 1 and that's route 2, and route 1 is equal to route 2. So now we're going to set our equation out. And we can rearrange that equation to give you the enthalpy change for reaction. So if you don't understand this, please go and have a look at my earlier videos that explain exactly how we do these calculations. So let's have a look at the next problem. Here we're going to calculate the enthalpy of formation of butane using the values of the enthalpies of combustion. So have a go at doing this and then I'll present the solution next. So we could write a balanced equation as before. And this time we write down the combustion product, so arrows are actually pointing downwards. the values in and multiply it by the number of moles. Finding the two sets of arrows that do not oppose each other, and they make up root 1 and root 2. So root 1 is equal to root 2 and then we write our equation down and we're going to rearrange it to give us a value of the enthalpy of formation. So if you've not come across Hess Law before, have a look at my other videos where I've actually explained what Hess Law is and how you can use it to calculate enthalpy changes, and then come back and do these problems. If you have any more questions, please get in touch with me using the comment box and I'll be happy to help. But I hope you found this set of videos useful.